Okay, and then in the final exercise, you need to calculate the net force or the resultant force in here. So, with respect to the force Q1, so I put in here something like this. This is a right triangle. So remember that to solve the right triangle, you can use the Pythagorean theorem and the trigonometric functions. And then in this case, you know this, so you need to calculate this angle in here and maybe this distance in here. So I'm going to calculate this distance. So it's the hypotenuse, so that's equal to, I'm going to write an x, so that's equal to square root 0.1 squared plus 0.15 squared. So I'm going to try that on the calculator. So square root, square root 0.1 squared plus 0.15 squared. So the distance in here is 0.18 meters. Okay, and then with this distance in here, you can also calculate the angle, so you can take that opportunity. So shift and tangent and the inverse of the tangent, so 0.1 over 0.15, so 33.69 degrees. Okay, so that's the angle. And then at first you need to calculate the force. So Q1 it's positive, Q2 it's positive, Q3 it's positive. So this Q3 it's higher than Q1, so it's pushing this charge from here to here, and it's Q2 it's higher than Q1, so it's also pushing the charge Q1, so from here to here. So I'm going to try to draw again our coordinate system, so something like this, and then I'm going to draw this vector in here and the other one from here to here. So you need to calculate the component in the x-axis and in the y-axis, so something like this, and then the sum of the forces in the x-axis and in the y-axis. So first of all, from 1 to the charge number 2, it's the same formula, 9 times 10 to the 9, and then 3 times 10 to the minus 6 times 4 times 10 to the minus 6, all divided by the distance, square the distance, so it's 0.15 squared. So it's 9 times 10 to the 9, and then 3 times 10 to the minus 6, or 4 times 10 to the minus 6, and all divided by 0.15 squared. So the force from 1 to the charge number 2 is 4.8 newtons. And then the force from 1 to 3 is the same, so 9 times 10 to the 9 times 3 times 10 to the minus 6 times 5 times 10 to the minus 6, and then all divided by the distance, and the distance is 0.18, so 0.18 squared, so that's important. And I'm going to change this value in here, so 5, and then in here 18, so it's 0.17, 4.17 newtons. Okay, so that's very easy. So it's this force in here, 4.17 newtons, and this one is 4.8 newtons. So this is the x-axis and this is the y-axis. And then you need to calculate the sum of the forces in the x-axis, also in here, something like this. So it's this one, 4.8, and it's positive. So this is positive, positive, negative, and negative. So it's 4.8, and then the component in here for the force 4.17, that is plus 4.17. The cosine of the angle, so the angle is 33.69, and then you can write that in the calculator again. So 4.8 plus and 4.17 cosine of 33.69. Okay, so in here it's 8.27 newtons, and then the forces in the y-axis, it's only this one in here, so this component, so this one, and you're going to have another one in here, so this one, something like this. Okay, so this one and that. And here it's only minus 4.17 sine times sine of the angle, 33.69. So minus 4.17 sine of 33.69. So this is equal to minus 2.31 newtons, and then with these two forces you can calculate the net force. So the resultant is equal to square root 8.27 newtons squared plus minus 2.31 newtons squared, and then again you can use your calculator. So the square root 8.27 squared plus 2.31. So I'm only thinking here the sign because it's negative times negative and it's positive. So the result is equal to 8.59. So that's the net force in here. And at the end, to find the angle, you can use the tangent, the inverse of the tangent, and it's always the same, minus 2.31 over 8.27. So shift in the tangent, this is 8.27, sorry, it's 2.31 over 8.27. So this is the angle in here, so minus 15.61 degrees. And that's all, guys. You only need this one in here and this another one in here. So I think it's very easy, and that's all, guys. So good luck with your final exam, and see you later.